For Ivy League? No, for Ivy League, they mostly will see your SAT score and academic results, not that much, because that's like the baseline, because almost everyone will have very similar academic results, right? So to differentiate, they'll look into your SAT scores, your ECS, and your your statement of purpose. That is the most important one. So they mostly select students reading that. The reason behind that is most students who get in, they'll probably have like, on average A. So that's not the differentiating factor. Differentiating factor is why do you want to pursue a course? What's your background? What do teachers tell about you? Those kind of things. So recommendations, statement of purpose, these are more important. Okay, so before we discuss that paper, this is what we did last class. If you remember, these are the different types of oscillation damping out there. So I'll now give you the definition for what damping is. I'll provide you a small description for each type of damping, and then we'll see there's this thing called resonance. It wouldn't take much time, maybe 20 minutes. Then I'll discuss your test papers. Okay, because we're almost at the end. So, right, can anyone remind me what was damping? Like 1 mark, it's a 1 mark question. What is damping? Very good, that's exactly what it is. Okay, it's the loss of energy due to resistive forces or work done against resistive forces, right? So you'll find that if a system is undamped, right, so it'll continue to oscillate without any change in amplitude. So this is called undamped, and there's no change in damping or amplitude. However, there's something called underdamping. This is more important for us because this is what happens in reality. What's underdamping? You will have decrease in amplitude, but it happens gradually over time. Okay, that's called underdamping. That's typically what happens when you have, let's say, a pendulum oscillating, or you have most oscillating systems out there. This is called underdamping, right? Then we have these two. One is critical damping and one is overdamping. What are these? So critical damping is the damping in which your system comes to rest in the shortest possible time. The time taken is very small. And overdamping is a damping in which it takes a very long time to come to rest. Okay, so I'll give examples of them as well, but let's just go through them one more time. I have mentioned them last class. Can you give me an example of an undamped system? A system that doesn't lose energy to the surrounding. Yeah, so something oscillating in space, something that's oscillating in a vacuum, because most of the energy loss is due to what? Work done against air resistance, right? So if you don't have air resistance, the thing was supposed to oscillate perpetually. An example of that would be this one here. So if I take let's say a mass spring system, right? So let's say mass spring system, right? So I take a mass spring system here and I make it oscillate. So I'll put some mass here and I'll bring it down here. So it keeps oscillating. And you'll find that it will oscillate like this perpetually, right? Because what is not happening here? Any energy loss to the surrounding, right? But if I introduce energy loss to the surrounding, see how the thing looks like, okay? So I'll add my mass here. And do you see there's a slider on the left that says damping? The slider under gravity damping? That's the amount of damping you're looking for. So if I increase my damping, you see that it comes to rest like that, right? So it lost energy. So let's bring it down again. See, it's quite heavily damped, right? Now, if I do that, what do you think will happen? Predict. Full damping. What do you think is supposed to happen? Acha, dekhi ki hai? Was it critically damped? Or was it heavy damping? Or was it still under damped, but heavily under damped? Yes, why? Because it did go up and down. Okay, critical damping or over damping, easy way of recognizing them is that they don't do one oscillation even. So look at this one more time. So I take my mass here and bring it all the way down here. See what it does. It goes up and then down and up. So it does a couple of oscillations, right? So that but it stopped, right? So if I had to plot the graph for this, right, how would the graph look like? It'll look something like this. Like that, right? It comes to stop very rapidly. So it is still under damping, but critically damped and over damping kerokom dekhte. Amar ei animation allow kore na, but I'll show you what critical damping is. Critical damping is this, okay? That it just stops. Okay, so our dekhai critical damp is you let go of it and it just stops. Okay, what's heavy damping or over damping? I'll release it and it'll stop, but yeah, so if I release it, it just goes like this. Like, it'll take a very long time to stop. Okay, so yeah, we have three types of damping out there: under damped, heavy damping, or over damping, and critically damped. Is it okay? So we discussed these things last class. Right, one more time. What is damping? Damping is a process by which your system loses energy to the surrounding, right? An example of this would be, I think this would be better. Yeah, let's do this. Okay, so it an oscillation system. See what happens. So what kind of damping is this? Under damp, right? Because it is going on, but it dies out eventually, right? What is this? Still under damp. It did multiple oscillations. That's how I think. Yeah, under damp, right? But I stopped it with my hand, right? Now, what is this? let it oscillate. Right. So I don't think I can do it here, but so that's critically damped because it stopped right away. Our heavy damping is possible, but heavy damping would be this, okay? Gradually come to rest like that. That's heavy damping, okay? An example of heavy damping, I think you mentioned last class, was the one in the doors. That mechanism they have in doors, you'll find that you can't slam the door. So the door will just slowly come to stop, right? So that thing at the top is actually heavily damped, okay? And if it was under damped, what would it do? It'll swivel like one of those doors you have in diners, back and forth, right? So that's called under damped, okay? Yeah. So the more friction you have, the more damping it is. Under damping occurs when the friction is gradual and the friction changes with your motion. So, for example, how does air resistance work? When is it the highest? Yeah. So as you go faster and faster, it goes faster and faster, right? So that's why it gradually dies out. That's under damped, right? Over damping is when the friction is a constant high value. Okay, so it's a constant high value, very high value. And critically damped is a constant low value. So when it's very high value, it will stop, right? But the friction is so much that the deceleration is very heavy. So it's slowly coming to rest. You're there last class, right? Remember that example I showed with the magnet, right? So critically damped took place when who was only responsible for stopping the system? The aluminum. Heavy damping took place when the aluminum and what else was there? Friction, because this is double the effect, right? So it's heavily damped. Another example would be when you drop a pendulum in a honey. So you drop the pendulum, right? Oscillating pendulum in honey, right? What will it do? It'll fall. It'll fall very, very slowly. Because why is that so? There's a lot of drag, but on top of that, there's something else that's even more upthrust. There's a simple upthrust, right? So only slowly put it. So that's very heavily damped. Okay. Right. So what are practical applications of damping? Is it good or bad? So damping is generally a good thing. Okay, I'll show you with practical examples how damping is a good thing. Because resonance is something which is a bad problem, right? So we'll try to fix that. But before I move on, are you okay with this? So I'll give you notes in a minute, but I just want to understand whether you have figured out what we did last class. Okay, so before I give notes on that, I need to do something else, and I'll give notes on everything together. Page 85. Go to page 85. Make it fast, page 85. I'll show you another video. Okay, সবাই একটু স্ক্রিনে দেখো. What I'll show you right now is going to be bread and butter for you if you go into mechanical engineering. So let's say if you have plans to be a mechanical engineer, right? This has to be like every time you do anything, right? This thing is what you need to take into consideration. It's called resonance. Okay, so let me show you what this is.
So what is ClickUp? ClickUp is an all-in-one productivity software where you can manage everything and anything related to your work.
Right, so I'll see your demonstration right now. And the demonstration is this. Okay, let me explain what this is, and then we'll try to figure out what is going on, okay? So it's saying that you have this base at the bottom. Do you see the green color thing? It can move, okay? And on top of it, you have three structures made up of glass, three different sizes. And on top of each of them, what do you have? A mass, right? So what we'll do right now is we will start to make the base move with a certain frequency. But before that, I need to teach you two different terms. One is called natural frequency, and the other one is called force frequency. So what is natural frequency? So natural frequency is the frequency at which something oscillates on its own. So energy day, you see that? That's its natural frequency. So this natural frequency is now different. So natural frequency change for it depending on what? You can hear the sound change, right? The sound change. So that's the frequency changing, right? That's called natural frequency. I'll give you more examples of natural frequency. So if I hit this table right now, you'll hear a sound. That's natural frequency. Natural frequency of the wall is going to be different, right? Because everything vibrates. And when they vibrate, they have this natural rhythm for vibration. Everything in the universe, starting from quarks, like, leptons, muons, and everything that you learn, the up, down, and everything, they're all vibrating, right? Similarly, atoms vibrate. We know that, right? Then things vibrate. Everything has a vibration because of the energy they have, right? But when you hit them, right, they also vibrate. That's the natural frequency. So what's the natural frequency of a pendulum? You take a pendulum, you move it to a side and release it. Isn't it doing it on its own? This is its what frequency? Natural frequency. What's forced frequency? Forced frequency, I'll force it to oscillate in a way. So it's this. Is it naturally doing it, or am I forcing it? Forcing it, right? That's called forced frequency. So natural frequency is something that oscillates on its own. Forced frequency is something that you make to oscillate with, like, push, right? So it turns out if these frequencies match, right, something very strange happens. Observe. So amra nicher base data, the green color thing is going to provide you what frequency? Force frequency. The blocks on the top, they have their what frequency? Natural frequency. Observe what happens. So do you see that the base is moving? So it's vibrating, right? And things get very strange very quickly. Let's just see what's going to happen right now. It seems like very normal. Base is vibrating. Do you notice that the blocks are slightly wobbling? Wobble korteche. Acha, don't worry, you'll see. So as I keep increasing the frequency, right? Nicher frequency kintu barteche. You can control the frequency like a fan regulator. And you'll start to notice one of them is misbehaving. It's not machaneta. Yeah, do you see the tall one is a little extra, right? So as it starts to oscillate, this is nothing. Just wait what happens. So as I keep increasing the frequency, right, you'll start to notice that the three are not vibrating the same way. One of them is actually vibrating a little more, right? And they were here. So you can now clearly see one of them is not doing normal things, right? Which one is that? The tall one. And do you see that it's going out of control right now? 4 hertz. That is, so what just happened here is that the term that we use here is called resonance. Resonance is when your force frequency and the natural frequency are what? Same. The system goes into this overdrive mode where amplitude increases and everything increases, right? That is resonance. So your natural frequency 4 chilo. Middle natural frequency is a little higher. So wait for it to show its motion, right? So as I keep increasing the frequency, now do you see that the tall one is not doing much? But do you see that the middle one is now going out of control, right? Eventually, you'll see that it becomes like very exaggerated, like anytime soon. You'll start to notice it's oscillating with very high amplitude somewhere there. What is this natural frequency? 6.35, okay? So whenever your force frequency and natural frequency match, the system amplifies itself. Amplifies in what? Energy transfer. I'll pause for a moment. This is actually something you've learned before. It's superposition. Do you remember superposition? So when one wave, another wave have the same frequency, and like, they're coherent, they'll overlap each other, and what happens to the amplitude? Doubles up, right? This is superposition in what domain? Mechanical domain. Like we are superimposing two systems' actual frequency and vibration. So our natural frequency of this thing is 6.35. Like all the particles in it is vibrating at 6.35. The base is also vibrating at what? 6.35. That's why energy transfer is what right now? The best. Okay. So there's I don't think a very good example, but it's an example. See how this thing works with the swing. So, playground is swing again. So let's say a swing is going back and forth like that, and you want to apply force on the swing to continue the oscillation. So where would be the best place to apply force on the swing? When the swing goes like that and it's there, that you apply force here. Would that be the right place? No, I mean, there's nothing here. What are you doing right now? So as it comes back, you apply force, right? So if your force application matches with the frequency of the system, don't they go swing to start force. If you've ever been on a swing, you'll notice that if the person starts applying force, all before the tour, you're starting to go higher and higher, right? Why? Because your energy transfer and the system's frequency are now what? Matching. Kintu, let's say swing ta aste se before it can reach, তুমি force দিয়ে দিলা. একটু force পাবে, but will it be very efficient? No, right? Because aren't you slightly opposing the motion? Then you're applying the force. So you're not in, the right term is sync. You're not in sync with the system, right? When the natural frequency and the force frequency are same, right? Every energy transfer between the two systems is in what? Sync. So that's why what energy transfer takes place? Maximum. That is what resonance is. Resonance is the process or phenomena that takes place when natural frequency is equal to force frequency and results in maximum what transfer? Energy transfer. So that's when two systems will start to resonate. Okay, so let's see Chota Koinaki. So I'll keep increasing my frequency. So yeah, as you keep increasing frequency, do you see the tall one? It's not doing anything right now. Because it's not a very suitable system. Both of their frequencies don't match. But as I keep increasing frequency, even that small one, right, which you probably would think will not be able to vibrate much, will now start to vibrate quite reasonably, right? So see what happens. So frequency barachi. And you'll notice that the other two, right, are barely moving. But do you see the small one is now vibrating vigorously, right? So yeah, this phenomena is known as what? Resonance. Okay, is it good or is it bad? Like in let's say you're a mechanical engineer, right? And this thing happens. It happens. Okay, is it good for your system or bad for your system? So generally speaking, it's very bad. Okay, so we need to look into why it's bad, because under cello, like an advantage, disadvantage, and we need to learn how to prevent this. That's why we have this topic. Okay, not to learn about resonance. In fact, resonance used to be part of all levels sometime back. Because damping is related somehow. Okay, so damping and resonance, if you think about them, they're opposites. Damping is a process in which energy is what? Lost to the surrounding. And resonance is what? The process in which energy is given to the system with highest efficiency, right? So when a system is maximum efficient, what takes place? Resonance. If a system is not efficient, what starts to take place? Damping. Okay, so what are the consequences of resonance? So resonance graph here before we start. Do you see that I'm increasing the frequency here? It's called a drive-in frequency. And because I'm increasing the frequency here, what is increasing here? The amplitude. And do you notice that at a certain point, you have the greatest amplitude like that, right? That point is when your natural frequency and force frequency are what? Equal. Okay, so this is like what resonance is, right? I have a question out here. What are the implications of resonance? Like, is there any harm to it? So there have been lots of disasters that took place just solely because of what? Resonance, right? Do you know of any? No, earthquake, no. Earthquake, just earthquake. It's just, yeah. Yeah, it started to wobble, right? Yeah, so I think there's a video of it as well, but I'll tell you what this is. This is like a malfunction, design malfunction. So what happened was Golden Gate Bridge, San Francisco there. Okay, so it was built and it's a very long bridge. It's a suspension bridge. Basically, it's suspended with wires. Typical bridge, second that there are pillars, right? This suspension bridge, one of the biggest out there. So it's basically floating in the but it's very heavy and wind can't do much about it, right? But what happened is, 1930s at the right, a storm came along, and just unluckily, the bridge started to sway, right? And the wind that was blowing also started to give force to it. Turns out the natural frequency of the bridge and the wind blow jeta kortesil rate were what to each other? Exactly same. What did the bridge start to do? It started to go left and right vigorously because it started to resonate. And it couldn't stop. There's a video out there, like the whole bridge going up and down. Like people were like jumping off the bridge because it was going to break, right? So this is because of resonance. This is very old. But recently, something happened. It was UK because past paper chilo. Because your questions are not like this. I'll show you something. It's something called the Millennium Bridge. It's in UK. A Millennium Bridge right. So what happened here? Very unfortunate. Bridge banaislo. The name is Millennium Bridge. 2000 opening later, right? Bridge kholar din, it started to sway left and right, and it was deemed unsafe. Cannot. So since it's part of your syllabus, is in the book, I think. This is the bridge, right? So turns out wind ne problem chilo na. There was another problem out there. So first day on this bridge, like 80,000 people were walking over it. Open course matro. Bangladesh Podda bridge just everyone over same thing. It's just worldwide phenomenon. So 80,000 people were on this bridge here, and suddenly this bridge, right, started to go left and right by meters. মানে এই যে ধরো তুমি এখানে বসে আছো এই চেয়ার থেকে ওই চেয়ারে যাচ্ছ ওই চেয়ার থেকে এই চেয়ারে যাচ্ছ এভাবে যাওয়া স্টার্ট করছে, and they shut down the bridge, right? Eventually they found out, very bad design oversight, a bridge's natural frequency is 4 hertz. 4 hertz, 4 hertz, right? Turns out when people walk, right, on like with a fast pace, their frequency 4 hertz. So every time you press your feet on the floor, right, it's 4 hertz. So it turns out when people were like marching along this bridge, their frequency and their frequency key is the match unknowingly, right? And they started to wobble very badly. And then eventually it was shut down for 4 or 5 years, and they added these things on the side to fix the problem, and we'll learn how that fixes the problem, okay? But yeah, this is an example, but the most famous example of all, you find this in every textbook. World War II, France most likely, there was this army marching over a bridge, right? And the whole bridge just collapsed. Why? Because the army don't march for it, you understand, they do it in sync, right? And just randomly, that bridge had what frequency? Exactly same frequency, and the bridge started to wobble, and it can't take that much stress, right? It just broke down. Recent memories of 1986 football match like that. There was a football match, Liverpool versus Juventus, right? So the match is like a very important thing to look into stadium design. So people started jumping up and down. They do that. Like they were at the side of the stadium, up and down jump sync, right? So what a stand jump, it was like a makeshift stand, a steel stand, right? And they started jumping up and down, and their frequency matched the frequency of what? That thing, right? And the whole thing collapsed. Like people died because it was like four-story people just falling onto each other, right? Because the whole thing just collapsed. These are all what? Resonance in play. Okay, so resonance is generally a bad thing, but turns out we have changed things around. Now we use resonance for our benefit. So can you give me a couple of beneficial uses of resonance, if you have heard of any? I believe you know one of them. Resonance headphone, but resonance effect let's say your speaker is playing, pass a table vibrate for it. You can feel the table vibrate. That's resonance. Okay. Human bones have the same frequency as bass sound. So that's why bass doesn't play. You can feel your insides vibrate, right? So that's because natural frequency match. That's why some sounds hit you more. All right. But what's like a useful use of resonance? Very useful use. Yeah. What treatment? So the name is, and I think you heard of this, NMR? MRI? Chemistry NMR right? What is it? Have you learned it, Nagi Shikba? University? Sure. Okay. Let me clarify. So the thing that we have, it's called an MRI. It's called magnetic resonance imaging MRI যে জিনিসটা MRI কাজ করে কেমনে they make your body water molecules resonate কেমনে external frequency there and then it gives you a picture of what's going on inside. It used to be part of our syllabus এখন হচ্ছে ওটা অত details নাই. We have now something more complicated, the PET scan is now in our syllabus. So anyway, that's resonance. Our resonance হচ্ছে resonance cleaning and resonance break-in. So resonance use করে they used to break kidney stones. So what they'll do is they'll aim waves at your kidney stone. So you know what this kidney stone is, right? It's like a mineralized stone in your kidney. So এটা operate করে বের করতে হয়. But they used to powder it out. They used to give a frequency to it, and the frequency of that wave and the frequency of the stone was what same. The stone used to vibrate very vigorously, and what did it become in the process? Like a powder, right? They have stopped that process. What I've heard recently, because there's a side effect to it. Sometimes the stone breaks into smaller pieces, which are also big in size. So তখন it becomes more complicated because you just had one stone before, now you have multiple stones, right? So it are correct, but that's something you can do, right? So these are all resonance, are good and bad. Now, how do we stop it? So let's say there's resonance going on out there. How do you stop it? So resonance is a system being efficient in energy transfer, right? How can I make it inefficient? Yeah, dampen, right? So a very simple example would be তোমার ধরো হচ্ছে গাড়িতে ড্যাশবোর্ড থাকে না, গাড়ির সামনে যে জায়গাটা অনেক গাড়ি দেখবে ভাইব্রেট করা স্টার্ট করে একটা স্পিডে, যে গাড়ি যাচ্ছে একটা স্পিডে এভরিথিং ইজ ভাইব্রেটিং, পুরান গাড়িগুলোতে হয়, রাইট? সো যদি কিছু ভাইব্রেট করে না, আস্ক ইউ টু স্টপ ইট, রাইট? হোয়াট উড ইউ ডু ইনটিউটিভলি? তোমার সামনে হচ্ছে ওয়াশিং মেশিন ভাইব্রেট, ওয়াশিং মেশিন ভেরি গুড এক্সাম্পল আছে। ওয়াশিং মেশিন হচ্ছে রেজোনেট করে, সো কাঁপতেছে ওয়াশিং মেশিন, দেখবো ওয়াশিং মেশিন একটা পার্টিকুলার রেটে খুব জোরে কাঁপা স্টার্ট করে সামটাইমস, ওকে? সো হাউ ডু ইউ স্টপ ইট? Yeah, just hold it, right? So hold করলে কেন স্টপ করে? Yeah, you're basically taking energy away from it, right? So you're making the system damped. So to damp system, what you do is you add masses to it. Okay, it's called a mass tuned damping. So mass দিলে কি হয়, জিনিসটার natural frequency change হয়ে যায়, so it doesn't resonate anymore. Okay, so I'll show you an example of this. Yeah. The structure actually. So atoms vibrate, but natural frequency that's from the structure of the object. So the pendulum natural frequency is not because of the atoms of the pendulum, it's because of the length of the pendulum. So I mean length change করলে our natural frequency change হবে. Okay, so the structure is what makes it resonate. So the whole structure is one body, right? So the whole body together has its own oscillating frequency. No, ওটা কেন অসিলেট করছিল? ওই যে people started pushing down on it, they started marching. এটা হচ্ছে পিপলের জন্য, আর যেটা গোল্ডেন গেট ওটা বাতাসে, because it was a suspension bridge. এটা সাসপেনশন না। কোনটা? Oh, they use dampers. So dampers কে আমি এখন দেখাচ্ছি. So there's a very simple video for this again. So yeah, if you go into any form of engineering that has mechanics based on it, you will have to do these things. These are very common in engineering. So this is called a mass tuned system. So খুবই simple. Do you remember we did this before? মানে যে আমরা বেসটা সরাচ্ছিলাম বিল্ডিং গুলো and they started to resonate. See what's going to happen right now, okay? So I'm going to give a push to both of them, so they oscillate, and that's not good. The building will break. Okay, so I'm going to keep করবো right side এ দেখো উপরে একটা mass hang করতেছে, right? So এখন দেখো কি করে ওরা, yeah, so they'll open this mass and they'll push it and see what happens. You see the tall building stop wobbling, but the other one is still wobbling. So you উপরে যে massটা ছিল, ওই massটা কি করে? So when you try to oscillate the building, ওই massটা যদি free to move, the mass starts to oscillate, and the mass takes what away from your building? Energy. Okay, so this is what you call mass tuned dampers. এগুলা হচ্ছে buildings use for it. Okay, so এটা either এটাতে করতে পারো, or you can put what in your building? Springs. So springs go back and forth and they take energy away from it. Like Japan, they have like Richter scale 9 earthquake. কিছুই হয় না ওরকম, barely any damage, right? অনেকটা ছিল 6-7 এ শকিং এ পড়ে, you know? The Japanese buildings, their walls এর যে pillar গুলো আছে, they're damped. So when the pillars actually oscillate, there's actually oil inside the pillar. আমরা কি ইউজ করি? সিমেন্ট, রাইট? ওরা সিমেন্টে চাইলে দিয়ে অয়েল দেয়, so the building starts to oscillate, এটার অয়েলটা মুভ করা স্টার্ট করে, and as the oil starts to move, what does the oil take away from the building? Energy, right? So তার জন্য বিল্ডিংটা oscillate করে না। আর আরেকটা এক্সাম্পল দেখে, this is Do you know the type A 101? What is that? Type A 101. It's a building that has this inside it. So it's a 101-story building in Taiwan, right? ওটার ভিতরে এরকম একটা বড় বল আছে। এই বলটা is basically a mass tune damper. So earthquake হলে কি হয় দেখে তোমাকে। Yes, this is the damper, and এটা হচ্ছে earthquake এর সময় বিল্ডিংটা তো মুভ করার কথা। It's a 101-story building built on a fault line. I don't know if you know what a fault line is. ওইখানে earthquake হবেই। So they took the challenge that they'll build a 101-story building on the fault line, and they'll make sure it never breaks, right? So দেখো কি হয়, এই যে এখানে earthquake হলে এই বলটা by the way is not like a small ball, it's 4-story tall. So যখন earthquakeটা হয় তখন বিল্ডিংটা মুভ করে না, ভিতর বলটা কি করা স্টার্ট করে, মুভ করা স্টার্ট করে, and the building doesn't sway. So এখানে ওরকম ভালো দেখা যায় না, but এই যে দেখছো বলটা মুভ করা স্টার্ট করছে because there was an earthquake out there. Now all the energy of the building has gone where? In the ball. So অনেকে আমাকে like other gadgets বলে যে বল যদি বিল্ডিংকে ভেঙে ফেলে বাড়ি মারে, like a wrecking ball, সব দিকে বাড়ি মারা স্টার্ট করলো। So you'll notice at the bottom they also have water attached to the ball, springs. ওই যে দেখছো এখানে কিছু pistons এর মতন দেখতে, so ওগুলো আবার ড্যাম্প করে। So basically multiple layers of damping করে পুরো এনার্জিটাকে কি করে দেওয়া হয়, dissipate করে দেওয়া হয়। So eventually nothing happens. Okay, so yeah, these are mechanisms out there. It actually building এর ভিতরে একটা hollow, মানে if you look at the building, এই ভিতরে হচ্ছে sphere, right? এই উপরে I think 10 story মিলে এরকম বল একটা, so it's like উপরের stories গুলো মিলে, so the ball can move around there. It takes the energy away from the building if there's an earthquake. Okay, prior earthquake হয় এখানে, but it doesn't do much of a damage. Clear? So that's our chapter. Okay, so once more, damping, resonance, and opposites, right? Damping prevents what? Resonance. Okay. So yeah, I'll provide some notes to copy or not. Why is there a downward force on the bridge due to people making the bridge resonate? Yeah, so when people start walking on the bridge, they're applying force on the bridge, right? Like contact force. That is what oscillating the bridge. Will humans resonate? Yeah, humans resonate. Just certain sounds can make your body resonate. Right, so the note I'm giving you right now, this is for the last class. So last class, so these are the definitions. It's all about definitions in this topic. So damping, there are 4 types of damping out there, what these dampings are, and their examples. Okay, so it's a copy right now, and then I'll give you stuff for resonance. You can copy this next to page 82 along with this graph. This graph is important. Okay. Yeah, I'll update the class notes today. Just pending us because chapter the shesh so actually go to go. And yes, if you have any questions, let me know. Check how can I find the natural frequency for this cup? That trial and error কি করব trial and error তে আমি যদি সাউন্ড দেই সাউন্ড পাচ্ছ রাইট বাট আবার যদি এটা করি sound similar but then if I use my keys here I wanted to change it because two surfaces hit and produce a sound but I want its own natural frequency. How do I find that? See if it vibrates. Achha, very close. I don't know if you've heard of this. There's this, show of ability. Opera singers are for it. They take a glass, right, and they go to the highest pitch out there, like sing for it, and their voice can actually crack the glass. Have you heard of that? Right. Why is that so? Because they go to such a high note, right? Where wine glass or frequencies sing. So if you want to show your ability to reach high notes, right? So a glass cracker is the thing. And why is that so? Once your voice reaches that frequency, that's the force frequency, and the glass has natural frequency same, what does the glass do? Vibrate too much, and because it's thin, what does it do? Crack, right? Of course, you can't sing every time to find this. So what you do is you take like an external source here, like a sound source, and you keep increasing the frequency. And at a point of a glass taki korteche nije theke kapteche. That's when you understand you've reached natural frequency. Okay. It's for our paper 5. Paper 5 egla lage. I'll put all together. Did you start your application? আজকে রাতে কি করবা? হ্যাঁ ওই সেটাই ওইটার কথা বলছো মেসেজিং খুব ইম্পর্টেন্ট that's what they read. Yeah, right. Paper 5. Paper 5 হচ্ছে after magnetism I do paper 5. There's a lot of experiments on magnetism in paper 5. After magnetism, the chapters that we have don't have experiments. So paper 5 can be start after magnetism. So maybe mid-November. Let me know if you're done. And the graphs there, I think you guys copied the graphs last class. Double masters. Yeah. No, I know people who have done like 3 masters. Yeah. It's like mostly to go to some place. So like they did their first masters in Bangladesh. Now they have to go to some other country, right? So they could do a master's there. So the rule is that after you do your master's, you have to get a job to stay back. So they get a job. So they go to another country to do master's. So they've been master hopping. So they keep doing that until it's like, some country decides to keep the. No, that's the thing. You can't keep doing the same thing. So they keep changing their field. So you have to say that now I'm more mature and enlightened. So now I decide to go to this field. And then you say, no, I've realized that this is not the future. And then I go that field. So you can't keep doing the same thing. There's some common masters people pick, like MBA is the one. It's very generic, right? But it's the one that they don't give scholarships. So that's why people avoid that. But there's like environmental science, and then there is cybersecurity. These are like general. Anyone can join them, even if you're from a philosophy background, right? You can do cybersecurity masters. Political science. It's oh, so this is a very good job prospect. Mostly not in Bangladesh. So you can join NGOs, lobbying companies. You can join, United Nations branches. Basically, you work on policy. What policy would be right for a country? You set policies for other governments. Mostly contractual work, but there are a lot of. It's a very niche market, but there's like good prospect there if you're into it. Aeronautical engineering in Bangladesh. Like, is there any university for it, or is there any prospect for it? Because we don't have a aeronautical industry. Like, we don't make any planes, right? So aeronautical engineering is only for companies that would build planes, right? So, and there are like 3 in the world: Boeing, Airbus, Lockheed Martin, right? So those are all in Europe and USA. So that's why there's no scope for it. But there's another branch which is basically aeronautical engineering. The one you said. This is flight engineering. This is about maintaining an airplane. For that, you don't need to do like a 4-year degree. Yeah, it's like basically all the airlines, right? They need a flight engineer. So if you don't know, most planes that are very large and go very far, right? There are 2 pilots and there's an engineer on board to fix the plane if something goes wrong in the air, right? That has good prospect because Bangladesh has a lot of airlines and it's going to grow in the future. The way people do it is they do like 4 years bachelor's in any science, and then there's this course that they provide, just like how pilots have flying school. So there's this aviation academy. So it's not really a 4-year bachelor's degree; it's a 2 years diploma degree on top of your bachelor's, right? So it's a specified field. So most of these are in Uttara. You'll have like I think 3 of them. They provide this training. In Bangladesh, yes, but at the moment it's very saturated because the chemical engineers, they mostly work for industries. These industries already have enough engineers, so there's no growth prospect here. General studies. General studies shouldn't get just general studies. So the places where you should go if you want to learn chemical engineering, there are two places. একদম hotspot. একটা হচ্ছে Alberta, Canada-তে, আর একটা হচ্ছে Texas. The reason হচ্ছে এইসব জায়গায় হচ্ছে there are a lot of oil fields. So oil যেখানে থাকে ওইটার আশেপাশে ইন্ডাস্ট্রিতে hydrocarbons, right, filled with chemical engineering plants, like some amounts of chemical engineering লাগে ওখানে. So these are the two hotspots. And let's say you go to Scandinavia to do this thing, chemical engineering. ওদের তো তেল নাই, ওরা তো carbon neutral or carbon net music করে না. They use renewable resources. ওইখানে you're like a villain. If you want to go and work in an oil company, right? Like aeronautical engineering, or you want to join like the aviation industry? Yeah. So turns out like the aviation academy there, they will take you without after A levels, and you can do courses there. The problem is that you're just doing a diploma, which is basically they're just teaching you about one airplane and how to maintain that airplane. That's more or less it, right? So future prospect is little limited. So you can work for airlines in Bangladesh, and the airline companies actually train you. So most of the companies here, they'll actually train you. But the problem is that if you want to go abroad, and there's a big crisis of this abroad right now, they're looking for pilots and engineers for airplanes, right? You need a lot of certifications. That's the problem. So eventually what I see is like some of my students who have done this, right? They go to another country, they take the certification, they work there. Then you need multiple examinations because the regulations there are very strict. So you need a lot of certification before you can put your hand on a plane. So that's the problem. So in Bangladesh, you can probably just do it through 2 years degree. You can't do it abroad. So you have to restart all your certifications. So you're not legally allowed to practice without those certificates. Very similar to that. Market research. So it falls under, it's called qualitative and quantitative analysis. So it's you try to understand market through data. That's very easy, but also through sentiment. So it's called a FGD, focus group discussion. You ask people and see what they feel because the numbers don't show that. So basically, my major was in that. What's your like future ambition? If you're looking for like easy future, like easy future in the sense that you'll definitely get a job, right, and not be unemployed, that is computer science. I know it's I have students who have actually went for computer science full scholarship and they dropped it because they just can't bear it. They didn't know about computer science before they went. So they were very good students. They took computer science because it's in right now. They went to the university first computer science course. They hated it, and they didn't want to do it for the next 4 years. Now they're doing like environmental science or something, random stuff. So computer science is actually not for everyone, but it has good prospect always. Yeah, that's the thing. If you don't like it, it's not going to be that useful. I mean, you'll just struggle through the 4 years, and then eventually you don't have passion for it. You wouldn't really like it because you have to do a lot of self-development there. Computer science is just the platform, but you need to learn yourself a lot of extra languages and everything, which they won't teach you in your university. So it's up to you. In fact, I feel like most students can get into computer science without even getting into a degree because most of these stuff you need to learn is available online. And then nowadays they hire people without bachelor's degree. You just need to show that you can make a project in that language. So that's why if anyone wants to get into CSE, I would just say just start right now. Just start coding. But if you don't like CSE, just stay away from it as much as possible because you'll hate it. I think if you want to go abroad, mechanical engineering has some prospects still, right? And chemical is there as well. But as I said, there are some locations where it's very good, but there are some locations where there's no job. And mechanical, you'll have more or less good prospect everywhere because we'll always be building things, right? So that's there. And what else? Electrical engineering was good, but now it's all automated, so there's no prospect for it. AI shop করে দেয় এখন, so এটা কোনো, but civil engineering is very good. So civil engineers, road constructions, building, it's called public works. That has very good demand. So yeah, civil engineering is actually not bad. But just make sure you go into something with a bit of research, because I've seen a lot of students will just start something, right, and halfway through they'll realize it's not for them, and eventually that has a much more detrimental effect. Okay, and notes for resonance. So it will be done. It is shesh kore aske jay, okay? So resonance, page number 86. So there's a graph and these three definitions. If you guys are planning for what major you should take, right, there's actually a very good tool out there. So ChatGPT, right? So no, let me tell you. So no one knows how to use it. So basically you tell your persona, like what you like, what you do, what you enjoy and not, and then it'll give you like one of the best outputs out there. It's like very, very accurate. So use that, because the students will go and like, what pays the most in 5 years, and then they'll say this and that, and they'll just look for that, right? But put in like what you enjoy, what you like, so that at least you won't hate doing what you're doing, right? So, and it gives very good results. You should try that. It's actually an issue. You like civil engineering? Yeah, because there's a lot of drawing in it, architectural drawings, but these are engineering drawings, like roads and highways and designs and stuff like that. So you'll find some creativity there. Oh, what subjects do you have? What subjects do you have? Do you like computer coding? Have you done any coding? Then you can try computer science and engineering, not computer science. Computer science is not worth it, but computer science and engineering, like microprocessors, fabricating PCB boards. Yeah, you like computer engineering, but the thing with engineering is that once you start, right, you'll start hating physics. This the physics we do, right? It's actually very basic. And once you start seeing that physics has no numbers and just alphabets, and writing random equations with no final answer, then you'll start hating it. So just because you like physics or just because you like chemistry, that is not really a good choice. So these will have prospects. Computer science আশেপাশে থাকলে ভালো, because computer science is ever changing. There are 4 years আগে graduate করছে, ওরা তো AI চিনতো না। এখন it's like all AI, machine learning. 4 years পরে আরেকটা জিনিস হবে। ইঞ্জিনিয়ারিংটা না, সো হ্যাঁ কভার হবে, সাইবার সিকিউরিটি থাকবে না। সাইবার সিকিউরিটি তোমার হচ্ছে ইভেন্চুয়ালি মাস্টার্স হিসেবে করতে হবে, বিকজ ইঞ্জিনিয়ারিং কি শিখবা তুমি, ওই যে হাউ টু মেক লাইক আ মাইক্রো প্রসেসর, অ্যাকচুয়াল ডিজাইন কেমনে করতে, সিলিকন দিয়ে ওয়েফার বসায় কেমনে অ্যাটম বসায় বানাতে হয়। সো দিজ আর লাইক কম্পিউটার সায়েন্স এন্ড ইঞ্জিনিয়ারিং। আর কম্পিউটার সায়েন্স যেটা, ওটা তো বেসিক কোডিং, ওটা আজকাল 10-12 ইয়ার অলসো ভালো পারে ইউটিউব দেখে। business. শেষ copy করা আচ্ছা ঠিক আছে টেস্ট পেপার কি questions আছে problem বলো let's discuss last second আচ্ছা দাঁড়াও did you give the test নিছো আচ্ছা নিয়ে আসো yeah tell me which questions you have problem with 1 and 2 1 and 2 আচ্ছা বুঝছো এমন just 5 minutes করে দিই আচ্ছা তারপর 5 minutes পর তারপর যাই 2b2 আচ্ছা আগে এটা করে নিই right so question number 1c1 and 2 okay so it says an amount of 0.18 mole of ideal gas is held in an insulated cylinder fitted with a piston as shown in figure 2.1 atmospheric pressure the pressure on the outside right this pressure is 1 into 10 to the power 5 the volume of gas suddenly increased from this to that. For this expansion, calculate the work done by the gas and hence show that the internal energy changes by 30 joules. So what was the formula for work done? Yeah, pressure into change in volume, right? So whenever you have work done on a gas, so work done by or on a gas is equal to pressure into change in volume. The pressure that we have is 1 into 10 to the power 5 into what is the change in volume here? So change in volume here is 2.1 into 10 to the power 3 minus 1.8 into 10 to the power 3 divided by, if you want your answer in joules, right, you have to convert the cm cube to what? Meter cube. So divided by 10 to the power minus 2 cube. That's how you convert centimeter cube to meter cube, right? So check করে দেবো কত আসে 30. Okay, so 30 joules. Because you're pushing it out, right? So when you're pushing it out, it means that you are providing a pressure either equal to or greater than the atmospheric pressure. Because this is moving out at this direction, right? Suddenly increase. What pressure are you moving against? Atmospheric pressure. So you're doing work against that pressure. See, it says here the atmospheric pressure is that much, right? And then you're going outwards. So you're doing work against how much pressure? Yeah, and that's the amount of volume change. Okay, so the inside pressure is not 1 into 10 to the power 5. It's obviously changing because volume is increasing. But you're doing work against which pressure? The external one, right? And the question was, what is the work done by the gas? Okay, so imagine you have a chamber like this. There's gas inside it. As I push it outward, right? What are you pushing out? The atmosphere. Determine the temperature change of the gas and state whether there's a change, whether the change is an increase or decrease. Determine the change in temperature. How would you find the change in temperature of the gas here? We know mole number, we know energy, pressure, volume. So how do you find change in temperature? There's one formula here only. PV equals to nRT, right? So PV equals to nRT. I need to find the change here, right? So what's my pressure? 1 into 10 to the power 5. 1 into 10 to the power 5 into, you can do for 2 different volumes and find the answer. Or if you do the difference, right, what would the answer be? The difference. Okay, so এখানে difference কি ছিল? 2 into এটা তো already বের করছি নাম্বারটা কত ছিল 30, right? Yeah, so 30 equals to 0.18 into what is the value of R? 8.31 into this will become del T. Can know del T because this is based on a change, right? So how much is del T? Check this here. 30.06, 20. So that's approximately 20 degrees Celsius or 20 Kelvin. Or Kelvin is achha na? Is it an increase or decrease? This is important. Okay. Determine the temperature change of the gas and state whether it's an increase or decrease. Okay. Decrease. Yes. Why? Yeah. So when you do work on the gas gains internal energy. Temperature rises. This is the work done by the gas. The gas is pushing the atmosphere away, so it's losing its own energy. And whenever something loses its own energy, what happens to the temperature? Decreases, right? So change is 20 Kelvin and decrease. I'll provide the reason here. Since work is done by the gas on the surrounding. Since work is done by the gas on the surroundings. আচ্ছা এখানে একটা thing chilo. The answer for this in the mark scheme, I want to discuss this. This is one question they actually wrote in the mark scheme that they canceled the question. This was the question. I'll show you what they wrote. This happened like twice. I remember only 2 times ever happening. This is the answer. The 3 marks were removed as insufficient data was given in the question. The insufficient data part এখানে কি হচ্ছে? As you push this one outwards, right? এই চেম্বারে যে ভলিউমটা চেঞ্জ হচ্ছে। Volume যখন চেঞ্জ হয়, what also changes? The pressure inside, which we don't know how it changes because we do not know like the proper structure of this, right? So আমরা এখানে assume করে নিচ্ছি the pressure is constant. What you did here would be right to find the energy gained by the atmosphere on the outside. The atmosphere has that amount of work done on it, right? But এই গ্যাসটার ভিতরে যে pressure change হচ্ছে, we do not know that value. তার জন্য this answer is not fully appropriate. Probably this was removed because insufficient data was provided. Okay, so everyone probably got 3 marks here. Right. তারপর next point also. 3B1. State how the mass of water is determined with the heater switched off. Yeah, আবার বলো কি বলছো? So that the mass of the water you should have mentioned that to allow us to find the amount of water that melted due to the atmosphere. Because the atmosphere will melt your water, right? We want to know that, and then the process you said is right, eliminate it, right? But we wanted to know how much the atmosphere melts the water by. Yeah, right. Without the check key allow percent. Or বলছে heat required to convert without 3A. বলছে to make allowance for heat gain from the atmosphere. So the word was atmosphere that you need to write. এটা কি বুঝছো কি? হ্যাঁ তুমি যেতে পারো। এটা কি বুঝছো what this is? This is basically why do you need to keep the heater off? answer হচ্ছে 2. Determine the water that melted due to the atmosphere. Okay. আচ্ছা আমি I uploaded the marks. Did you find it? আচ্ছা so তোমরা দেখে নাও যদি তাও কোনো কিছু না বুঝে থাকো আমাকে বলো. Okay, and I think we did this question in class. এটা so এটা অনেকের ইস্যু ছিল, but this is in your notes as well. Right, regarding the notes, I'll upload them today. All a simple harmonic motion.